So in this video, we want to solve the trig equation sine of x times secant of x times tangent of x, all divided by cotangent of the quantity pi over 2 minus x. And we want to find all the angles that satisfies that equation for the interval 0 to 2 pi inclusive. And that 2 pi tells us that we want to find these answers in radians, not in degrees, and for one lap around the unit circle. So the first thing we want to look at is our Trig Identities Hexagon, which helps us recall the fundamental trig identities. And if you remember, going from side to side here on horizontals across, those are the cofunction identities. So the sine of pi over 2 minus x is cosine. You can also go the opposite direction. So the cosine of pi over 2 minus x is equal to sine. So the cotangent of pi over 2 minus x, that's cotangent right here. If we head horizontal, we see that that's equivalent to tangent, since those are cofunction identities. So we can swap out this denominator with tangent. So sine of x, secant of x, tangent of x is in the numerator, and now with that cofunction identity, this is all divided by the tangent of x. Okay, now we can look at trig hexagon again for sine of x times secant of x. And if you recall, sine of x is here, secant of x is here, and they make a hinge here at tangent, right? They point together to tangent in the middle, and that's the product identity pattern. So sine times secant is tangent. If we wanted to do that over here, right, sine times cotangent is equal to cosine, or secant times cotangent is cosecant. That pattern holds true throughout the identity hexagon. So we can swap out sine times secant, that product, using that identity to get tangent of x times tangent of x, all divided by tangent of x, and that equals 1. So now that we have same thing in the numerator as the denominator, those are common factors, so they can cancel. And then we'll have tangent of x is equal to 1. And to undo the tangent function, we need to do the inverse. So the value of x is equal to the arctangent, or tangent inverse, of 1. So that's asking the question, what angles on the unit circle from 0 to 2 pi, because that's our interval that we're working within, how many of those angles and where are they located that have a tangent of positive 1? So we're going to need to revisit the first quadrant of the unit circle. So we'll go ahead and sketch those special angles from quadrant 1, and we're working in radians, so this is 0, pi over 6, pi over 4, pi over 3, and then the positive y-axis is pi over 2. And if we follow the pattern for remembering the coordinates in the first quadrant, we always start with the y value down here at 0, and we'll follow the pattern 0, 1, 2, 3, 1, and then back again, same pattern, 0, 1, 2, 3, 1. And the quadrantal angles, they have their coordinates now, 0, 1, and 1, 0. In the middle, each of these is going to get divided by 2. And then we square root. So we'll have the square root of 3, square root of 2, square root of 3. The square root of 1 is just 1, so we don't bother with the square root on top of those. And then that's how you can fill out the first quadrant from memory. So the tangent, if you recall from earlier lessons, tangent is defined as the quotient sine of x over cosine of x. The cosine is the y coordinate, the sine is the cosine is the x-coordinate, the sine is the y-coordinate. So the tangent of 0 would be y divided by x, 0 divided by 1, which is 0. Right? The problem that we're looking for is the angle that has a tangent ratio of 1, which means the x and y coordinate have to be the same. And that happens here at pi over 4, because square root of 2 over 2 divided by itself, but divided by square root of 2 over 2, that is a tangent of 1. So our first solution is going to be at x equals pi over 4. Okay, now that's not the only place though where tangent is positive. If you recall the acronym that we learned for remembering where different things are positive on the circle, let's see if I can get away from that glare. All students take calculus. That's our acronym for the different quadrants. The A reminds us that all of the trig functions are positive in quadrant 1. Then the S reminds us that sine and its reciprocal cosecant are positive in quadrant 2. The T tells us that tangent and its reciprocal cotangent are positive in quadrant 3. And then the C reminds us that cosine and its reciprocal secant are positive in quadrant 4. We already found the quadrant 1 answer. That was pi over 4. And that would be our reference angle from quadrant 1. Tangent is also positive, though, down here in quadrant 3. So we need that angle, but in quadrant 3. So if this is pi over 4 as my reference angle, halfway around the circle would be 4 pi over 4. And then another pi over 4 from there would be 5 pi over 4. So x is equal to 5 pi over 4 would be a second solution to this trig equation. So we're going to go ahead now in the graphing calculator and check that those answers do in fact work. So in the mode here, first thing we want to do is make sure that we're in radians, which we are. And then we're going to store this first answer, pi over 4. Then we'll hit the store button and x. And then we can type in this equation up here at the top. So alpha y equals number 1. And then we start with the sine of x. And then this next one, secant of x, there is no secant button on the calculator, so we're going to need to use the reciprocal identity, which is 1, whoops, nope, now we got to fix that. Okay, so alpha y equals number 1. We want to do sine of x and then times. Then alpha y equals number 1. There we go. 1 divided by cosine of x, because that's the reciprocal identity for secant, 1 over cosine. And then that is times tangent of x. And in the denominator, there is no button here for cotangent on the calculator. So we're going to need to do the reciprocal identity again. So alpha y equals number 1. And then the reciprocal of the cotangent is tangent. So 1 divided by tangent of pi over 2 minus, oh, whoops. Gotta get back down under there. There we go. Pi over 2 minus x. Okay, close the parentheses on that denominator, and then we're going to get out of that denominator second math, and number 1 gets us the equal sign, and we want to check that that whole mess there is equal to 1. So when we use the equals from the test menu, that's asking the calculator to substitute in this pi over 4 value that was stored as x for all the x's in this equation. And then if it's true, it's going to return a 1. If it's false, it's going to return a 0. So we press enter and we get a 1. So that means that this pi over 4 solution does in fact check. So next we're going to store 5 pi over 4 as our new value for x. And instead of retyping that whole monstrosity up there, we're just going to arrow up, highlight it, press enter, and it retypes it for us, which is awesome. Press enter, and we get a 1 again. So we know that 5 pi over 4 also checks.